Have you ever wondered how the world began? What was there before Earth, the Sun, or even the stars? Let's take a journey back in time, way back about 13.8 billion years ago. Yes, billion, that's when our universe was born. We call this momentous event the Big Bang. No, it's not just a catchy name for a popular TV show, it's a scientific theory that explains the origin of everything we know. Picture this, a single point, unimaginably tiny, incredibly dense and hotter than anything we can even conceive. This was the singularity, the starting point of the Big Bang. Now you might be wondering, how can something so small contain everything? Well, it's one of the great mysteries of science, and that's what makes it so fascinating. Then, in a blink of an eye, faster than you can say supercalifragilisticexpialidocious, this tiny point exploded. But this was no ordinary explosion. It was an explosion of everything: space, time, matter, energy, all bursting forth and expanding at an astonishing rate. As the universe expanded, it also cooled down. The energy transformed into particles which then formed atoms. These atoms grouped together to form stars and galaxies, but that's a story for another scene. What's truly mind-boggling is that this expansion is still happening. Yes, right now as you're listening to this, the universe is getting bigger. It's like a loaf of raisin bread baking in the oven. As the dough rises, the raisins move further apart, just like galaxies in our expanding universe. So, to answer the question we started with, before the Earth, the Sun, or the stars, there was a tiny, hot, and dense point. A point that contained the potential for everything that exists today. A point that exploded in the event we now call the Big Bang. So, in the beginning there was nothing but a tiny, hot, and dense point that exploded and formed the universe. Now isn't that a bang-up tale to tell? Once the universe was born, how did the galaxies and stars form? It's a question that takes us back nearly 14 billion years into the past, right after the Big Bang. In the immediate aftermath of the Big Bang, the universe was an incredibly hot, dense soup of particles. This was a chaotic, formless era known as the plasma epoch. As the universe expanded, it started cooling down, a process that took hundreds of thousands of years. During this cooling period, something remarkable happened. The high-energy particles slowed down and began to combine, forming the first atoms, predominantly hydrogen and helium. This event is aptly named recombination, and with the formation of atoms, the universe became transparent to light, marking the end of the plasma epoch and the beginning of a new cosmic chapter. Now, with atoms freely moving in the universe, gravity started playing its part. These atoms began to clump together, drawn to each other by the irresistible pull of gravity. Over time, these clumps grew larger and denser, turning into vast clouds of gas. In the heart of these gas clouds, something even more incredible took place. The pressure and temperature rose to such an extent that hydrogen atoms began to fuse together, creating helium and releasing a tremendous amount of energy. This process, known as nuclear fusion, marked the birth of the first stars. The stars didn't exist in isolation though, they clustered together, forming galaxies. Some of these galaxies had hundreds of billions of stars, each one a glowing testament to the power of gravity and nuclear fusion. And so the universe, once a hot, dense soup of particles, transformed into a vast expanse filled with galaxies and stars. This transformation wasn't instantaneous, it took billions of years, a testament to the cosmic scales involved. So the stars and galaxies we see today were formed from the atoms that were created after the Big Bang. The universe's journey from a chaotic soup of particles to the structured cosmos we see today is a story of transformation, time, and the incredible power of natural forces. From the vast universe full of galaxies and stars, how did our solar system and our planet Earth come into existence? Let's rewind the cosmic clock to around 4.6 billion years ago. Picture a massive cloud of gas and dust swirling in the infinite expanse of space. This is not a random cloud but a nebula, a stellar nursery where stars and their planets are born. The gravity, that invisible force that keeps us grounded, starts pulling this nebula together. As the particles within this cloud draw closer, they begin to spin, creating a flattened disk with a bulge at the center. It's kind of like a cosmic pizza with a clump of dough in the middle. Now, the middle clump, the heart of this celestial disk, is under immense pressure and heat. So much so that it triggers a process called nuclear fusion, where hydrogen atoms come together to form helium. This fusion releases an incredible amount of energy, birthing a new star, our sun. But what about the rest of the disk? Well, the leftover material that didn't become the sun isn't wasted. These particles of dust and gas start sticking together, forming larger and larger clumps. Over millions of years, these clumps grow into planetesimals, the building blocks of planets. And so, in this cosmic dance of gravity and matter, our Earth is born. Earth, along with other planets, is formed from the leftovers that didn't become the sun. Our planet, just a tiny speck in the vast cosmos, finds a stable orbit around the sun, setting the stage for the story of life to unfold. Isn't it fascinating to think that we are all made of stardust, remnants of a cosmic event billions of years ago? And that's how our Earth was born, from the leftovers of the formation of the sun, in a universe that started from a tiny, hot, and dense point. Isn't it amazing to think about how everything we see around us, including ourselves, started from a tiny, hot, and dense point? It's been quite a journey, hasn't it? We began with the Big Bang, a monumental explosion that initiated the creation of our universe. From that cataclysmic event, atoms formed, eventually clustering together to create stars. These stars grouped into galaxies, vast cosmic neighborhoods, each teeming with billions of these radiant celestial bodies. Among these galaxies, our own, the Milky Way, birthed our solar system and the third rock from the sun we call home, Earth. This journey isn't just about the formation of physical entities, but also about the incomprehensible vastness of time and space involved. It's a narrative billions of years in the making and spanning distances we can hardly fathom. Next time you look up at the night sky, remember, you're not just looking at stars, but also a glimpse into how our world began. Don't forget to give a thumbs up, like, share, and smash the notification button if you found this journey through time fascinating.